Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to discuss flood mitigation and nature-based solutions. So last time we understood the concepts of flood hazard, exposure and vulnerability. How flood exposure is very critical, to translate any hazard into a vulnerable situation. We also learned the methodology for flood risk assessment, various components that are involved in a flood risk assessment framework, and we explored the role of remote sensing and GIS in flood hazard mapping and flood risk analysis. The learning objectives for today's lecture is we'll understand various flood action stages and flood mitigation. We'll explore the various types of structural and non-structural measures and nature-based solutions for flood risk reduction, and we'll discuss relevant case studies for flood mitigation. Starting with the very simplest terminology, that there are different stages where flood alerts are usually given by various flood agencies across the globe. So the very preliminary is flood watch. So flood watch is an indication which asks you to be prepared. So usually the agencies will issue a flood watch when conditions are favorable for flooding. It does not mean that it will surely flood, but there is a possibility that flooding can be likely. Second is flood advisory, where they are cautioning you, so you have to be aware. So a flood advisory is issued when the flood warning, when the flooding is not expected to be bad, but enough to issue a warning. So flooding may happen, it may not be that severe, but yes, it may disrupt some operations. So it sometimes there is a word which is also called as nuisance flooding. So this nuisance flooding is usually where your water will occupy your streets and other properties, which is very minimum to cause some significant damage. So it will be kind of waterlogged situation. It will not damage any life or property, but still it is kind of nuisance. So that this nuisance flooding term, this is widely used in the United States to coin these type of flooding incidents where there are short duration inundation, but not devastating. So when flood advisory is issued, there is some caution to be exercised, because it can further lead to a situation which can be life threatening. Otherwise it is just a normal situation where the flood is expected to be within certain limits. Last is flood warning. So flood warning is a time where you have to take action. Hazardous weather event is imminent or already happening. So if the event is imminent or happening, the flood warning will be issued. Now in India, Central Water Commission is the nodal agency which maintains all the river gauges, particularly due to its jurisdiction, and secondly it issues flood warning. Apart from that, there are state water agencies also, but it is a central agency. So it has several categories. So what is normal flood? A river is said to be in a normal flood situation when any of the flood forecasting sites, the water level is below the warning level. We have seen all these levels, that warning level, danger level, then high flood level. So we have all seen these levels, so we are familiar with these terms. Above normal flood, so if the water level in the river at the forecasting site, it touches or crosses the warning level, but it is below the danger level. So in that case, you call it as a above normal flood, and usually yellow color is assigned to signal this category. If yellow color is there, it will be above normal flood. Next is a severe flood. So if the water level of the river or at the forecasting site, it touches or crosses the danger level. So danger level is very important. If crosses the danger level, but it is below the high flood level, that is HFL, then you call it as a severe flood. It is denoted by an orange color. An extreme flood, where the situation is said to be very extreme, that the water level touches or crosses the HFL, and then the color assigned is the red color. So this is the most severe case where your HFL is breached. So in 2022-23 there was a very devastating flood in Narmada, where HFL was breached at around 7 to 10 stream gauging stations in its gauged history. So that was a very devastating flood where these things happened. So here is a pictorial representation. You can see that Highest flood level, that is extreme. Then severe, so if the water level crosses the HFL, it is extreme. It is between HFL and danger level, it is severe. Between danger level and warning level, it is above normal, and if it is below warning level, it is normal. So that way it is to be interpreted. What is flood mitigation? So flood mitigation is usually proactive measures which are taken to reduce the long-term risk of flood damage to people, property or infrastructure. So it includes both any kind of strategic planning is required, or to strengthen the structural defenses. Both will be a part of the flood mitigation. Now why it is required? Because climate change is altering the frequency of extreme events by modifying the hydrological cycle. So floods are becoming more frequent and more intense. Unplanned and rapid urbanization is causing the existing waterways to shrinken, and that is also not in line with the natural drainage of the river, and that is one of the causes of frequent flooding. So whatever many people are encroaching the floodplain, so the floodplain encroachment, that also leads to tremendous damage. So effective mitigation would help us save life, reduce economic damages and build a resilient community. So flood mitigation measures are broadly classified into two. One is structural measure and second is non-structural measure. Under structural measure, one is storage and detention reservoirs, creation of levees or embankments, floodways, channel improvement techniques, watershed management and nature-based solutions. So nature-based solution is one of the upcoming structural measure which has been introduced. While non-structural measure requires floodplain zoning, flood forecast and warning, evacuation, relocation and flood insurance. So coming to the structural measures, the traditional approach of flood management is always to decrease the intensity of flood peak and increase the time base, so that you can either hold or divert some water or you can always increase the carrying capacity of the channel so that a flood is passed very effectively. So the name itself says structural, means you have to create some physical structures which are either used to control or prevent the flow of water. So it is a kind of fight against nature which have to be put by creating human made barriers. Now structural measures are usually aimed at keeping the floods away from the people, so safeguarding them in a way. So for example, if you have a house, if I create a big boundary wall across the house, so I will not allow the water to enter the house, so thereby I am safeguarding this particular house. Next is the storage reservoirs. So usually across a river, a dam is created. Upstream of the dam you will have a reservoir. So these are one of the very reliable and effective methods of flood control. A part of the storage reservoir is to absorb the incoming flood and release the flood. So there is a term called attenuation. So it will absorb more incoming flood and release that in a very time bound manner, so that the peak of the flood is lowered down, and that is not exceeding the channel carrying capacity. Next is detention basins. So detention basin, it consists of an obstruction to a river with an uncontrolled outlet. Now what do we mean by uncontrolled outlet? In case of a dam, you have some gates which can be operated. So if the gate is lifted, the water will come below that gate. So that is called a controlled outlet, where you have full control how much water to release in the river. But when you talk about uncontrolled outlet, it is whenever, like simple case of a bucket, if the bucket gets filled, the water starts spilling, that is an uncontrolled outlet. So where detention basin involves uncontrolled outlet, so if it exceeds the capacity, the water will start flowing, but it will provide a temporary storage and it will restrict the outflow rate. So that is the advantage of the detention basin. Now what can be the detention basin? The natural lakes or depressions in an area, they can be easily used as a detention basin. Next is levees or embankments. So levees are also known as dikes or flood embankments. They are earthen banks created parallel to the course of the river, and they are meant to confine the course such that water is not spilled. So for example, if this is the river cross section, so this is your bank full stage. So once water is over the bank full stage, the water starts spilling on both the ends. Now how do you avoid that? To avoid that, you create earthen embankments or levees on both the sides. So these levees are created, and these levees will now increase your bank full stage to this level so that you can pond more water. So this is the extra water delta V which can be held up due to the creation of these levees. Now levees require considerable care and maintenance. Also they have been proved to be more effective measure, because by day and day in many rivers, more probably the alluvial rivers, the carrying capacity of the rivers have reduced. So for the given stage which was earlier safe, now the floods have been received, so that is why these levees are providing additional buffer. Next is diversion channel or spillways. So diversion of flood water as flood control measure involves excess water can be diverted from one part of the basin to another, or either it can be the same basin or it can be another basin. So you might have come across the term inter-basin water transfer. So inter-basin water transfer usually is adopted between two basins, where one is a surplus basin, second is a deficit basin. So by that you minimize the floods in a surplus basin and you supply water in the deficit basin so that it does not faces drought. Next are spillways. Spillways are again they are regulated structures, so they control how much water to be released, and they avoid the dam from getting overtopped and failed subsequently. Channelization of river. So river channelization is like modifying the natural waterways to increase the flow capacity and control the flows, either by straightening, widening, deepening or reinforcing the channels. So you can see that this is a river channel of a river in Puerto Rico. So two parallel channels can be seen. So the channel is made more stabilized. Its flow carrying capacity has been increased so that the flow can easily be diverted and it does not exceed the channel carrying capacity. There are several benefits that it improves navigation, it reduces soil erosion, but there are some negative impacts also, like ecological consequences, that they affect the habitat diversity, they increase the flow velocity, and it can result in other ecological consequences. Next is watershed management. So this is a very common kind of structural measure, where land treatment is done by cutting down and delaying the runoff before it gets into the river. So if you plant more trees or more agriculture, so the flow velocity gets retarded, and due to that the time to peak can be delayed, and you can attenuate the flood. Next is anti-erosion works. So flow pattern along a river path changes considerably after every flood. So floods will drastically change the river path. So there are anti-erosion works like bank revetment, spurs, which are provided first to control the erosion, as well as they retard the velocity of flow. Now there are, with advancement, there are new geomaterials like geotextiles, geotextile bags, geotextile tubes, sand-filled geomatrices, neo-web submerged veins. Now they are being used in construction of revetment, spurs and gryons. So you can see that this is where the geotextile material is laid, and then over the top of that, so vegetation will be there and it will be very streamlined. Now coming to a relatively newer terminology, that is nature-based solutions. So nature-based solutions are the central idea is that nature provides solution to all problems. So you can measure that thing, you can sustainably manage and restore with nature, while you are enhancing the ecosystem services, and you address a variety of social, environmental and economical challenges. So your nature-based solutions uses natural processes and ecosystems to reduce your flood risk in a very sustainable manner. Now they are seemed as a critical means to adapt to climate change. They do not offer only social and environmental benefits but also economic gains. Like there are vegetations which are on the floodplain, so these vegetations would provide some economic value also, and they retard the soil erosion, so they are retaining the fertility of the soil. So these kind of things are much prevalent. Also they provide an opportunity to reduce the carbon sinks as well. So there is a concept in nature based solution of blue, green, grey infrastructure. So grey infrastructure is resembling to what we call concrete. So these are the engineered facilities which are created all over the place, but they are environmental unfriendly and not sustainable as well. Green infrastructure can be anything natural or artificial green space that is created in a city to enhance its ecology, stormwater management and the landscape patterns. And lastly, the blue infrastructure, so the surface water bodies in and around the cities. It can have multiple functions like ecological, cultural, flood control. In India, the cultural aspect is more, rivers are treated more as mothers. So there are a lot of festivals like Kumbh Mela is one of the largest cultural gathering which happens across the world, and other river festivals. So they increase the cultural significance of a river. So in the blue infrastructure you have rivers, lakes, ponds, wetlands, floodplain and aquifer. Green infrastructure can be forest, open spaces like parks, lawns, etc. Bioswale, rain garden, mangroves and urban farms. Grey infrastructure can be dam, seawall, pipe, embankment, water treatment plant. Wetlands, we are all very familiar with the term wetlands. So they are very effective nature-based solution in attenuating the risks from flooding for a shorter return period. So for shorter return period they can be very good, and their ability is very limited when the return period increases, because as your return period increases your flood magnitude also increases. So for medium return periods 10 to 50 years they are very limited, but if the flood is of a very high return period greater than 100, it may not mitigate floods. So wetlands act as natural sponges to store and slowly release the excess water, either it is from rainfall, snowmelt or runoff. Now since wetlands retard the speed of the water, they reduce the volume as well as they control the erosion. Now coastal wetlands in having mangroves, that is a vegetation grown in the coastal areas, they act as a physical barrier to the storm surge, and they to a large scale prevent coastal erosion and as well as prevent against any coastal damage. So you can see that these are the wetlands in the figure. So if due to urban development these wetlands are destroyed, then what happens? Then the flooding is more prominent. You can see that the flooding is more prominent. So in the Chennai 2015 floods, one of the reason was the several wetlands were encroached, and that has also resulted in widespread flooding. Riparian restoration. Riparian restoration is the ecological restoration of interface between the land and water along the rivers, streams or other water bodies. So it involves actively replanting native vegetation or passively reducing disturbances like grazing or allow natural regeneration. So whenever any replanting activities to be taken, it should be ensured that you only plant native species so that they are more adaptable to that environment. The goals of riparian restoration is to improve the water quality, to control erosion, to mitigate flooding and drought as well, and enhance habitat for wildlife. Floodplain reconnection. So it is a process where barriers like levees are removed and allows the rivers to periodically interact with the natural floodplains. So while river restoration involves re-establishing the river's natural physical, chemical and biological processes. So however, these are some suggested measures. It may not be equally applicable in all conditions, but still they have been thought of as a way to rejuvenate the river. Next is urban green infrastructure. So urban green infrastructure uses natural or semi-natural systems to mitigate flood risk, or by slowing, storing and filtering the storm water. So in case of urban areas, storm water is a main contributor of the flood. So if we can manage this properly, we can reduce the urban flood systems. So examples can be porous pavements, green roofs, rain gardens, vegetated swales, etc., because they allow more infiltration and less surface runoff generation. Non-structural measures, they involve something which is not physical, but it is more on the planning side, like policies, practices and programs that reduce flood risk by managing the human interaction with floodplains rather than controlling the water. So these are called soft strategies that work by keeping people and property out of harm instead of trying to keep water out of the developed areas. So one of the non-structural measure is floodplain zoning, where your floodplain is already defined that this region comes under 1 in 5 year flood, this region comes in 1 in 25 year flood, this region comes in 1 in 100 year flood. So the region which is more recurrent to floods, that is 1 in 5 years, so that is more frequent, so that is a protected area. So in that protected area, the legislation has to be very strong. Next comes the regulatory area, where the frequency is bit low. So there are some regulations like you cannot have X kind of buildings or Y kind of buildings, or you cannot use for that purpose, etc. And the another zone, as you go out, that particular zone is very rare when it will be affected by flood. So there the regulations can be different. So like that, floodplain regulations are made. Usually what is a floodplain regulation? That in the floodplains no permanent structures are to be created. So in the recent times you might have seen that in Himachal and Uttarakhand lot of flood damages have been observed. The vulnerability has been more because of the exposure. People have created their houses within the floodplain, so which is usually not permitted by law, but that has been created, which has caused widespread damage. Again, floodplain zoning, it regulates the land use or zoning policies, which again regulate the risk in high risk areas. So this will reduce the economic exposure and vulnerability to the flood events. For example, if you are planning hospital, government office, etc., do not plan in the area which is frequently flooded. So this area should not be parked. They can be used for parks or other recreational things where the economic damages are less. And for example, if you want to plan a nuclear powerhouse, you can never plan it in zone this, and if you are planning it here, again you should plan with a very high factor of safety, otherwise that can have large scale consequences. Next is flood forecasting. It is considered to be one of the most cost effective non-structural measure. So here it involves lot of data analytics, that you get lot of data that is mostly a real time data. So real time data involves lot of telemetry gauges which transmit the data or through satellites, where you have stream gauge measurements, precipitation measurements. There are some models which forecast as well, and that data is fed into a already developed model. That particular model can give you the output that based on your input, this is the likely output, that this much area will be inundated, what will be the depth of inundation, and based on that alerts will be sent to the authorities to plan the evacuation measures. Let us say if an area is projected to have 1 meter of water depth, then how many houses to be evacuated, where the people have to be shifted, and so on. The evacuation has to be planned. Early warning systems, so they are like timely warnings issued via sirens, SMS or media for evacuation. So there is a mobile application called FloodWatch India, which was launched on 17th August 2023 by Central Water Commission. It uses very advanced technologies like satellite data, mathematical modeling and other real-time monitoring to deliver timely and accurate forecasts. So in this, based on if the water river level is increasing, then your decision can be made. It can be transmitted through radio, through SMS and other systems, and people can be shifted to other places where the damage of the flood is not felt or very minimized, and the relief and rehabilitation or rescue can be carried out. One more thing is creating more public awareness. Or community programs like educating and empowering people that you should not create any property in the floodplains. Like this is the example of a flood gauge. So just to give an idea that if the water level comes in the red zone, then it is very danger. So that way, or if they see water is steadily rising, they should inform some local officer, so that that can be information can be passed further. And finally, that emergency planning and evacuation, where you do some pre-analysis that if a flood is of 10-year return period or 20-year return period, how much area will be inundated. So based on that, you have some plans that if X area is inundated, how should we rescue them, how should we evacuate them. So a blueprint is prepared, and that blueprint ensures responsibility, that this agency is responsibility for evacuation, this agency will be responsible to disseminate the alerts, and then the plan is chalked out. Flood proofing is also one of the advanced concepts, where any combination of structure or non-structural measures, changes or adjustment to a building can be done so that it reduces or prevents flood damage to the structure and its constituents. So simply, if we want to state that flood proofing is any effort a property owner can make to reduce a flood damage. So this is the existing condition, and this is the flood water that usually starts to develop. So first one is the dry flood proofing. So what happens in dry flood proofing, you can place barriers outside your doors and windows. So till that barrier is placed, your water will not enter the door and window. Next is raising the structure. So you can raise the depth of your structure so that the water level will not touch. Raising the structure with a fill. So you can raise the structure with a fill, some kind of material. Next is wet flood proofing. So wet flood proofing is where you allow the water to enter the house and pass through the other place so that it does not damage the house. So you can see here more clearly that dry flood proofing involves sealing buildings, walls with waterproof compound so the structure is watertight. When the structure is watertight, no water enters the structure. Also, it should be ensured that walls are very strong to withstand the hydrostatic force of water, because water will exert hydrostatic force from all ends. It may be possible that due to saturation there will be a buoyancy force which will be acted in the upward direction. Wet flood proofing, what happens, you allow the structure to flood. For example, the water can enter the structure and then it can leave the structure. So the building should have very strong anchorage so that you avoid the building to float, and it should have flood vents or permanent openings that allow the water to flow in and flow out without causing any foundational damage. So here you can see that in the sub basement they have provided these kind of openings, so the flood waters will enter and then they can be leave. If not, then they can be easily pumped as well. So let's discuss a case study. So this is a case study of Lower Tapi River. So you can see Lower Tapi River is somewhere here in Gujarat. So this is a dam which is Ukai Dam, which is on the downstream. There is a Lower Tapi River. So from Ukai Dam you can see this is a reservoir of Ukai Dam. Then the Tapi River flows and then it meets the Arabian Sea ultimately. The Surat city is located around 120 kilometers downstream of the Ukai Dam. So these are the different bridges or gauges that we can see here. So there is a weir also and there is a gauge station. So there is a Nehru Bridge location in the Surat city where the warning level is 8.5 meter and danger level is 9.5 meter, which is given. The population density and everything is documented. There are different zones of the Surat city. So the authors, so this study is by Vora et al. 2018. So the authors analyzed the flood levels and corresponding discharge for the historical flood event. So what was an interesting thing? The Ukai Dam was constructed in the year 1972. So prior to the construction of Ukai Dam, 1968 was a major flood event where the flood stage was close to 12 meter, that is 12.08 meter, and the flood peak was 43,000 meter cube per second. After the construction of Ukai Dam, the largest flood was 2006, where the flood stage was 12.4 meter. Remember, the warning level was 8.5 and the danger level was 9.5. So all events above that are flood. While so you can see both the levels are quite close to each other, but the flood discharge in case of 2006 was 25,768. So the authors found that due to construction of Ukai Dam, the carrying capacity of the river was reduced drastically. So due to that, what happened earlier, for it used to carry, although it was flood, but it used to carry the same amount of discharge. Now for a little lower discharge, very low discharge, it is getting flooded. So such alarming reduction in the carrying capacity of the river was attributed to extensive development of the floodplains, then siltation of the riverbed due to efflux of a weir. So this is the methodology they followed. So they used the data, they performed flood frequency analysis, then they computed flood quantiles for, so as per IS 12094, if you want to flood proof agriculture area, you have to consider 25-year return period, urban area it is 100-year return period. Then a hydrodynamic model HECRES was utilized, and then levies were proposed and they were prioritized also. So you can see that these 1 to 12 are the different locations where the measurements were taken, and you can see the left bank and right bank, and the top of the left and right embankments were proposed. So in most cases it was seen that the flood levels which were simulated for 125-year return period, they were below that embankment levels. So these are the structural measures where levees were proposed to mitigate flood risk by preventing the overbank spillage and confining the flood flows within the main channel. So you can see that the study also provided criteria that if you want to construct levees which are of low priority, intermediate and high priority. So you can see in red here, these are high priority areas. Now how the priority was decided? It was decided based on several factors. First is population, that was the population in that area. Then second is your what is the elevation of that area and other factors. So then red is the high priority, and here you can see mostly agriculture area that has the least priority. So the urban area has a high and intermediate priority. One more case study where the Tarai plains in Nepal, which are home to the indigenous communities that farm soils, that are enriched by annual floods. So they have used biodikes, again a nature-based solution, which can hold the earth and other material together and reduce the risk of erosion. So these biodikes, they are considered as green infrastructure because they are constructed entirely of plants such as bamboo, rattan and other tree roots. So they do not stop the floods altogether, but they can significantly reduce their impact. So the key takeaway from this lecture, that flood mitigation aims to reduce the long-term flood risk through a combination of engineering, management and ecological approaches. Structural measures offer direct protection but may alter the natural systems and require high maintenance. Non-structural measures focus on preparedness, land use planning and community engagement for sustainable resilience. Nature-based solutions complement traditional methods by restoring the ecosystems and working with natural processes to manage flood effectively. So here's an activity suggestion for you. You can review at least 2 case studies where structural or non-structural flood control measures have been applied. So here are a few reference material. The case study, this paper can be referred if you want to refer to the case study in detail. Thank you for your attention. In the next lecture, we'll provide a summary of flood risk assessment and mitigation.